Okay, so this is a little help for the assignment. So what we're looking at is three musical notes, C, E, and G. And if you play those notes, you'll get a C chord. And an arpeggio is where you play notes in a chord in sequence. So it'll be like boom, 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 and you would just keep looping around. Now, the specifics are the frequency. And that's how many cycles per second you have. So this particular C is 1047 hertz. The E is 1319 hertz. And the G is 1568 hertz. We'll learn more about this when we get to talking about sound. Now, the period is the length for one complete oscillation. In our case, an oscillation is up, down, and so this is what we would have on the Arduino. We have 5 volts and 0 volts. And the time that it takes to go from the first increase to the second increase in voltage is the period. And it turns out the period is equal to 1 over the frequency. So if you take 1 over 1057 hertz, you'll get 0.00. Put that in the calculator, make sure I get the number of zeros. So 1 divided by 2047. So it's 0.00955 seconds. So that's the time. Now, when we do this buzzer, the delay, and we're going to do, remember, delay in microseconds. So for a C, the period turns out to be in microseconds. So micro is this mu term, microseconds, 10 to the minus 6 seconds. In terms of this, it's 0.000955 seconds, which is 0.955 milliseconds. You multiply that by 1,000, and it's 955 microseconds. So that is the period. And you can do the same thing with these other notes, 758 microseconds and 638 microseconds. So those are the periods. Now the delay is going to be half of that. So you can take half of 955 and you'll get 476 microseconds. So when you do the programming, you will have a delay on high of 476 microseconds, and then you'll have a delay for the low part, which will be the same thing. And you can divide these by 2 to get the corresponding ones for C and E and G. So those are the delays that you're going to need. Now, to actually play 1 second worth, the way you do that is you go through so many oscillations. And an oscillation is going to be a for loop. So, for example, to do this, the note C, you would do for j equals 1, semicolon, j is equal to less than 1047, and then j equals j plus 1. So what this does is it's going to count through 1047 up highs and lows, which is a period. So this will make it so that it lasts for a second. And for the E, you do from 1 to 1319, and for the G, you do from 1 to 1568. And that'll make it so that each note lasts for 1 second. Okay, so what you'll end up having is 3 for loops. One to play the note C, one to play the note E, and one to play the note G. So you have 3 for loops. And so what I would do is I would define a variable. We want to use variables here. So just to let you know what I did, I defined 3 variables. Period C, which was the number of, basically the this had to do with the delay here. So if I had 955 would be the period for the C, my delay time would be half of that value, 476 microseconds, million microseconds. And then I came up with another one, I called it count C, and that was 1047. And that corresponds to the number of cycles, how many loops I have to go in my for loop to get 1 second of each one of these notes. So you can see you'd have a period E, a period G, a count E, a count G. And you'll need to define your counter. So I have 8 variables: period C, period E, period G, count C, count E, count G, the pin number 8, and the counter J, which doesn't have a value defined. And then you have 3 for loops that have a varying amount depending upon which note you're playing. And then in each for loop, you'll have digital write high, delay so many microseconds, digital write low, so many microseconds, then you'll have it high, and then you'll just keep looping that around, initially 1047 times for C, 1013 times for E, and 1056. And what I'm going to do here is I'm going to play this thing. So let's start this thing going and put my microphone near it. Okay, so that's what it's supposed to sound like. Now I need to find a way to turn this thing off. There we go. Okay, so that's what you should end up with. You should end up with your thing going boom, 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 forever.